Real world assets are becoming one of blockchain's biggest opportunities, but today's lending protocols still rely on one time collateral verification. The moment an invoice is paid, duplicated, or becomes fraudulent off chain, lenders are suddenly exposed to bad debt. For bankers, fintech lenders, invoice financing platforms, and tokenization providers, that means higher credit risk, expensive manual audits, and reduced capital efficiency. Wardens protocol solves this problem. Wardens protocol is the autonomous trust layer for real-world assets built on Casper, where AI agents continuously verify collateral, challenge one another, and are financially accountable on-chain. But here's a key difference: we don't trust our own AI agents. Every verifier must lock a security bond on-chain before participating. If another agent proves they submitted an incorrect or dishonest report, the protocol automatically slashes their bond and rewards a honest challenger. Trust isn't assumed, it is continuously earned. Let me show how it works. Before looking at the interface, let's look at the system itself. Wardens protocol is powered by Rust smart contracts built using the Aura framework and deployed on Casper. Casper acts as our trust enforcement layer, guaranteeing that every bond, challenge, reputation updates, and slashing event is transparent, verifiable, and immutable. Every critical contract path, including asset registration, trust scoring, dynamic loan to value calculation, dispute resolution, and bond slashing, is covered by automated testers. All 12 tests pass successfully. Behind the scenes, a backend orchestration coordinates three specialized verifier agents: parser, fraud, and registry. Everything you see in the UI is backed by live services communicating with Casper. Let's register our first collateral. This invoice is worth 1000 CSPR, issued by ABC Corporation and owed by XYZ Limited. When I click register, Warden's protocol submits a transaction directly to the Casper testnet. The assets now exist on chain. Notice that its trust score is 0 and borrowing is disabled. That's intentional. Wardens enforces strict guardrails that collateral must first be independently verified before anyone is allowed to borrow against it. Now let's verify this invoice. The backend orchestra dispatches verification requests to three independent specialized agents. To make this economically sustainable, we implemented the X402 micropayment standard. Each verifier initially responds with HTTP 402 payment required. The orchestra automatically pays the verification fees in CSPR, retries the request with proof of payment, and receives the completed audit. The agents independently analyze the collateral. Their results are aggregated into a final trust score of 94. That score is submitted to Casper smart contracts, which automatically updates the loan to value ratio to 75%. This allows lenders to price risk dynamically instead of relying on static collateral. High quality assets unlock more liquidity, while risky assets are automatically restricted, improving capital efficiency without sacrificing security. Since the collateral is trustworthy, borrowing is not enabled. I will borrow 700 CSPR and transaction is finalized immediately on chain. Now let's see when someone attempts fraud. I will register another invoice using the same issuer and debtor information. To a traditional lending protocol, this duplicate collateral might go undetected until it's too late, but Wardens continuously verifies collateral throughout its life cycle. The fraud agent immediately detects that this invoice has already been pledged elsewhere. The overall trust score falls to 46. Because the score drops below our security threshold, the Casper smart contract automatically freezes the assets and reduces its loan to value to 0. Borrowing is blocked immediately. No administrator intervenes. The protocol protects itself automatically. Everything you have seen so far isn't just a local simulation. Warden's protocol is deployed to the cloud, where our autonomous agent network and orchestration backend run continuously on Microsoft Azure, while our Nest.js frontend is hosted on Vercel. For phase 2, we completely re-architected the protocol into 8 modular smart contracts using the order framework. The most critical addition is the Covenant engine. Instead of relying on manual administrators to pass bad loans, the Covenant engine translates our autonomous agent trust code directly into on-chain DeFi guardrails. It operates on a strict threshold encoded directly into the Rust smart contracts deployed on Casper. If an asset scores 85 or higher, the contract grants full access, allowing maximum borrowing. If the score drops between 70 and 84, it enters a monitored state, automatically lowering the perimeter loan to value ratio. Below 70, the contract trigger drop function, instantly blocking new borrowing. And if the fraud drives the score below 50, it triggers breach mode, permanently locking the collateral and diverting reverse funds to protect the lender. We also introduced the privacy score, a Merkle-based data registry that commits verification evidence to the blockchain without leaking sensitive invoice data publicly. By separating the current engine, bond vaults, and challenge codes into distinct contracts, the protocol can now be upgraded safely into DAO governance without risking locked capital. Most importantly, it is 100% on-chain. We integrated a LiveNet executor so that every asset registration, trust update, dispute resolution, and a slicing event is recorded through real Casper testnet transaction. We don't have to trust our UI. You can verify every single protocol action directly on Casper Explorer. Wardens protocol transforms trust from one-time assumption into a continuously verified economic system. Every verification is accountable, every challenge is transparent, every decision is enforceable on Casper. Thank you.